Welcome again, folks, to another session of Euclidean geometry where we are doing riders. Now, in this particular rider, there are no numbers at all. By no numbers, I mean you won't be given any size of the angles here. Now, remember what I said to you folks. I said for Euclidean geometry, number one, make it a point that you can state and understand all the theorems. It is number one. Number two, make it a point that you can prove the theorems. That is number two. The last one, make it a point that you can recognize those theorems from any given diagram. Now, by recognition, I mean, in your statement, we are going to sometimes give you clues by giving you some of the names of the components which are stated in your theorems. Let me take you through this and make an example. You are given a circle O. Remember, circle O means circle with center O. Now, I said, we are going to give you clues there by naming the components which are in your theorems. When we say circle with center O, you would remember that the angle at center of the circle is said to be twice the angle on the circumference of a circle, provided they are subtended by the same arc. Now, that is clue number one. It continues to say circle O with tangents. I want to underline that. Tangents, RS and RNP. I want to stress this. Tangents, RS and RNP. Let's do that there. Tangent RS and tangent RNP. If you know your theorems very well, you will know that there's a theorem that says tangents from the same point are equal. Now, you see both tangents are from a common point R. That means that RS is exactly the same as RN. Remember that. Let's continue again. We were told that there's a center O. Look at your diagram. I'm recognizing theorems now. There's a line drawn from center to circumference of the circle, which is known as the radius. Can you see that the radius is making contact with the tangent? Again, there's a line from center to circumference, which is a radius. Can you see that this tangent and this radius are making contact there? Remember the theorem. A tangent and a radius are perpendicular at a point of contact. Let's continue now. They say that two lines are tangents at points S and N. R and P touches the circle at point N. RST touches the circle at point S, as the statement is saying. Radius NO, let's look at that radius. NO, it is this radius. What happens with it? It is produced there. Cuts the circle at M, there, and meets RS, produced to T. Now, we produce this, it cuts the circle there, and it goes on to meet RS produced at that point. Folks, with this statement. We have been given all the answers for the questions that they are asking there. Question number 1. Why is angle OSR 90 degrees? Let's go and look for angle OSR. Angle OSR. Which angle are we talking about? We are talking about that beautiful angle there. For 1 mark there. Why is it 90 degrees? Now, I would say to you, Father Christmas is very early this year. It is May, the 15th of May, and Father Christmas is dropping to give us 1 mark for free. Remember, that is the center. This is the radius. This is the tangent. What do we know about them? They are perpendicular at a point of contact. Now, I'll just go there and say, my reason is tangent and a radius. Then for that, you score yourself that beautiful mark. I repeat again. Why is angle OSR 90 degrees? The reason is simple. A radius and a tangent are perpendicular at a point of contact. If you just say tan rad, we know what you mean. You have scored yourself a beautiful fat mark. Now, next question. Prove that RNOS is a cyclic quad. Let's go to that. RNOS. RNOS. We must prove that this is a cyclic quadrilateral. Now, let me underline that again. I said, state theorems with understanding. Cyclic quadrilateral has got 3 beautiful theorems. The first one, it says, opposite angles of a cyclic quadrilateral are supplementary. Now, if you want to prove that RNOS is a cyclic quad, it means that you should show me that in RNOS, the opposite angles, this angle plus that angle, are adding up to 180. If you can't do that, show me that this one plus this one, let's do this, are adding up to 180. Number 2, the exterior angle of a cyclic quadrilateral is exactly the same as the interior opposite angle. Now, if you have this shape, RNOS, if you can demonstrate that this angle is exactly the same as that, then RNOS is a cyclic quad. Last one. We know that if we have RNOS in that form, and we can prove that this is equals to that, or this is equals to that, which are angles that are subtended by the same chord. OS is subtending this one and this one, NR is subtending this one and this one, then we can conclude that RNOS is a cyclic quad. I've heard someone saying it is not a cyclic quad because all the vertices are not on the circumference of a circle. That is a very childish reasoning. A mathematical reasoning would be, if it does not meet one of those 3, then it is not a cyclic quadrilateral. Now, let's look at this one. Which shape are we going to use? Can you see that S3 plus S4 is 90 degrees? Beautiful. Now, can you see that? Remember, this was a tangent, meaning that it is a straight line which is produced to meet at that. Can you see that we've got angle S1 plus angle S2 plus angle S3 plus angle S4, which must add up to 90 degrees at 108, I'm sorry. Now that means that angle S1 plus angle S2 is also 90 degrees. What is the reason? There. Now, I'm going this way now. It's a tangent and a radius. I know that a tangent is perpendicular to a radius at a point of contact. Now, can you see that? I've got RNOS with RS produced to T. That situation. This angle is 90 degrees, that angle is 90 degrees, therefore RNOS is a cyclic quad. If I don't want to use this one, I can use this one. Can you see that this is 90 degrees and this is 90 degrees and they add up to 180 degrees and they are opposite angles of a quadrilateral. I'm sorry about that. Folks, I just want to point out something. In Euclidean geometry, we are teaching logical reasoning. Now, you must always be very careful of the previous question because it might help you in the other questions to follow. Now, by that, let's remove this now. We know that we are going to use this one and this one. We cannot use this one because we know nothing about those. We know nothing about those. This one falls off. Let's remove them and prove what they wanted us to prove. You know, I always say Euclidean geometry is one of the most easiest sections of mathematics. Why? Because all the answers are standing in front of you just saying, here am I, please pick me up. I'm the right answer for that question. Now, I'm going to start by saying LOSR was set to be 90 degrees. There, I can say proved in number 1.1.1. If you did not prove it there, you just say tan radius. Now, I know that here I must get a beautiful mark. Then I go on to say, but what I know again is the fact that LONR is also equals to 90 degrees. How do I know that? I did not prove it now. That is why I'm going to say it is because it's a tangent and a radius and they are perpendicular at a point of contact. I get another mark again. Where am I getting these answers from? They are calling me from there, saying, hey, Lachi, we are here. Now, this is 90, this is 90. I'm now going to say, but when I add LOSR plus LONR, I get 180 degrees. Why? Because they are both equals to 90 degrees. Not necessarily that they must be both equals to 90 degrees. Sometimes it would be 160, 20, sometimes it would be 80, 100. Now, I must give a reason now and agree. on that particular statement. Therefore, RNOS is concyclic. What does concyclic mean? It is a cyclic quadrilateral. How do you know that? There's my reason. Because opposite angles are supplementary. We have answered that question. Now here, I'm going to get, where am I getting the marks? For the reason, and I get the mark for my statement there. Beautiful, folks. Now, remember one thing. If you could not prove that this is 90 degrees, if you must use it here, remember it is 90 degrees. We will never say to you, prove that something is this if it is not that. We are not like that in mathematics. Now, if you could not prove that it is a cyclic quad, if in the next question you must use the fact that it is a cyclic quad, use it. We will never say to you, prove that something is a cyclic quad if it is not. If it is not a cyclic quad, I would say to you, is RNOS a cyclic quad? Give a reason for your answer now. In that case, if I'm saying is, it means it can be cyclic or it cannot be cyclic quadrilateral. Let's continue, my beautiful people. And now, for those folks who are overseas, I don't know how you write your reasons, but here in South Africa, please, it is acceptable. I don't want my friends from overseas to criticize this now. It is acceptable with us. But mathematics, as I always say, is a universal language. Now, if angle S1 is equals to X, that is a statement. Angle S1 is given as X now. What is angle S1? It is angle TSM, that angle. It is said to be equals to X. Determine with reasons. 4, let me underline that. Let's not underline, we put it in a rectangle there. 4 other angles which are equals to X. Guys, you see in this diagram, there are 4 other angles which are equals to that angle. They can even be more than 4. Now, for how many marks? 8 marks. Why? With reasons. Okay, let's see. This was said to be a tangent. All right? That is a chord. I repeat again, it's a beautiful one. We have a tangent, we have a chord, and we have the angle between the tangent and the chord. I'm talking about this angle. Still remember that theorem? The angle which is between the tangent and the chord is equals to the angle subtended by the chord in the alternating segment. This angle is equal to the angle which is subtended by this chord. In the alternating segment, there's minor segment, there's major segment. That means this angle is equal to this angle. Beautiful. Beautiful. My first angle is angle N2. It is equals to X. Why? Angle N2 is equals to angle S1. What is my reason? Tan chord. Now, those of you who are going to be writing the exam in June, both grade 11 and grade 12, I bet there would be a question on time chord. We can put a bet, 1 million, 1 million, you are going to get a question on time chord. Now, it would be 1 mark there, 1 mark there. 1 mark for the statement, 1 mark for the reason. Now, we can see that this is X. Where's another one? Alright, okay, it's fine, it's fine, it's fine. I can hear it calling my name, saying, here am I. Look at ON. It is the radius. Look at OS. It is the radius. Huh? What do we know about that? Radies from the same point are equal. For my American folks, radii. But because I'm Xhosa, I go radies. Radii from the same point. Now, can you see that? Triangle OSN is now an isosceles. What does that mean? It means that this angle is equals to that angle. Can you see that all the answers are there? I did not go to any of my friends or call anyone for answers. I'm getting them from here. Now, I'm going to say here, LS3 is also equals to, what am I doing now here? Angle S3 is equals to X. How do I know that? Because OS is equals to ON, which are a radii from the same point. I get 1 beautiful mark for that. Oh, now I'm looking for the other one. Folks, let's go there. We have proved that we have proved that quadrilateral RNOS is concyclic. Now, it means that if I have angles which are subtended by the same chord, those angles are going to be equal. Let me look for them. Can you see this? And that? They are subtended by chord OS. Beautiful there. Now, I'm going to say angle R2 is also equals to X. How do I know that? Same segment. Those are angles that are subtended by the same chord, because RNOS is concyclic. Now I'm looking for the last one. It is calling my name. Can you see that ON is subtending angle R1? The very same ON is subtending angle S3. Now, I can say that this angle is exactly the same as that. There we go. Angle R1 is equals to X. Why? Because they are subtended by the same chord. My beautiful people, if I was the examiner here, I would have said to you, instead of saying, give me 4 angles which are equals to X, I would have made it a bit challenging by saying, prove that OR bisects angle SRN. For how many marks? I would have said 8 marks. Show me that OR is bisecting angle SRN. Bisect means this is dividing this big angle into two equal parts. We have just done that. If it was that question, I was going to conclude by saying angle R1 is equals to angle R2, which is equals to X. Now, OR is bisecting angle SRN. Alright, let's do the last question. Prove that angle S3, where's S3? There's S3, is equals to half angle O3. It is half of that angle. Wow, folks, this is beautiful. Now, remember, we have a center there. There. I'm going to start by saying what I know is that angle O3 is equals to twice angle N2. Why? The angle which is subtended by the arc at center of the circle is twice the angle which is subtended by the very same arc at any point on the circumference of the circle. Now, that means that if this is x, this is 2x. My reason is going to be angle at center is equals to twice the angle at circumference. Beautiful. Am I not scoring my first mark? I do. And it is 4 marks. Now, remember that this angle is equals to x. Now, I would say angle O3 is equals to 2 times x. Let me get a mark there. Now, this is following from this. I want to show that angle S3 is equals to half angle O3. What is angle S3? But angle S3 is equals to x. How do I know that? It was proved in 1.1.3 there. I'm just going to say proved in 1.1.3. I get my mark there. Now, can you see that this is x and this is twice x? What does that mean? It means that if I want to get this angle, I must have that angle. Therefore, I'm going to say here, angle O3 is equals to twice angle S3. How do I know that? There. S3 is x. O3 is 2x. Then I can divide both sides by 2. I'm now simplifying this. Angle S3, I'm dividing both sides by 2 is equals to half angle O3. That's it. I have proved that. And I know that some of my friends are sitting somewhere there saying, why are you not just using the fact that this is equals to that? Meaning that now this is twice that. And you just divide by 2. But I'm saying to them, what did I do here? I did the same thing. Folks, I want to repeat again this. I'm going to preach this every lesson of Euclidean geometry. Your theorems are very important. state and understand them. When I'm talking about theorems, I'm talking about everything that you've ever done in Euclidean geometry from the young age up until you are as old as now, like myself. I want to ask you to subscribe to my channel, like our channel, leave a positive comment so that we can improve where we are improving. And I want to thank all my American friends who are commenting positively. There's someone who said I deliver good lessons and my handwriting is so very beautiful. I want to thank you, my friend. Mwah, to you. Peace out.